Here we are at problem number 3m, where we have the limit as x approaches infinity of the square root of x squared minus 2 minus the square root of x squared plus 1. Now, a lot of times we want to try and use direct evaluation, but if we try that, we would end up then with an infinity minus infinity, and really that just actually comes out to be an indeterminate form. So unfortunately, the direct evaluation is just not going to quite work here. Again, that is just one other type of indeterminate form, so we can't quite do that. Now, another alternative that we can do is trying to notice how these do not match. So we can't, unfortunately, just combine those either. They're really close, but again, we can't just combine them. But another option that we can do is what's known as multiplying by the conjugate. Okay, so really all this whole thing is all over 1. I'm going to take this entire piece and multiply it by the square root of x squared minus 2. And then instead of this negative sign in between them, I'm going to go ahead and change that to a positive. And we'll see why in a moment. And then we also have our square root of x squared plus 1. And again, in order for this actually to work out, we have to do it kind of like in that fufu type manner. So this entire thing is also then on the bottom as well. Because again, you're not then changing the way that this problem is actually working. You're just changing the way that this guy on the left looks. So in just that step, what we've done is multiplied, as you can see, we've multiplied by the conjugate. Conjugate just pretty much means the different sign in the middle, but all the rest is the same. So we still then have the limit as x approaches infinity of, now on this particular problem, I'm going to go ahead then and actually kind of show the FOILs so that way you guys can all see how all that works with the conjugate. So if we take this first times the first, really we have the square root of x squared minus 2 times the square root of x squared minus 2. Now, I can read x squared minus 2 by itself. I can just say I'm just going to square that then. Going with the outer, we just end up with positive square root of x squared minus 2 times the square root of x squared plus 1. I'm actually not going to go ahead and multiply that out, and you'll see why in like pretty much the next second. For the next one, multiplying the two innards, we end up with negative square root of x squared plus 1 times the square root of x squared plus 2. And then finally, for the last, we end up with a negative, I should say, times a positive gives us a negative. And then since we have that square root of x squared plus 1 times the square root of x squared plus 1, because it's being multiplied by itself, I'm just going to go ahead and rewrite this as the square root of x squared plus 1, and that is being squared. Again, just because it's being multiplied by itself, so it's the same thing as just squaring it. So this entire piece, the red and the green, is actually just the top part of that fraction. On the bottom, and the reason I did that is because I was running out of board space. But on the bottom, you still have 1 times that square root of x squared minus 2 plus square root of x squared plus 1. And so as a result, we can pretty much just rewrite that square root of x squared minus 2 plus the square root of x squared plus 1. The whole reason, and I said this second, we'll see in a second, and I apologize that it took a little longer. But the whole reason why we do multiplying by conjugates is hopefully that you can see something happening in the middle. And right about here with this inner red and this inner green, you can see that they are pretty much identical. The only difference is one has a positive and the other has a negative sign. And as a result, when you combine those like terms, they just actually end up dropping out. And so that kind of makes life a lot easier. So though it looks intimidating, though it looks like there's a lot going on there, those do end up dropping out every time you do the conjugate like that. Now we still have the limit then, as x approaches infinity, of, because on top of this square root of x squared minus 2 being raised to that second power, that square root and that squared are kind of inverses of one another, and as a result, they just end up canceling out with one another. And so then you're just left with what was underneath, that x squared minus 2. And then all the way over to the right, we have a minus. And the same thing will happen over here as well. That square root will end up canceling with that squared, leaving you with what was just underneath, that x squared plus 1. Now the reason I put parentheses around that is because this negative, originally that negative is in front, and that will actually be applied then to both of those terms, not just, that x squared. Okay, so just a little piece of information to kind of keep in the back of your mind. On the bottom, we still have that square root of x squared minus 2. I'm just going to rewrite these, plus the square root of x squared plus 1. Now at this point, I would say, okay, I'm going to go ahead and combine my like terms on top. So then we have the limit as x approaches infinity of x squared, really minus x squared. Those just end up dropping out. We have negative 2 minus positive 1. So we end up then with negative 3. We then end up with the same exact bottom, square root of x squared minus 2 plus square root of x squared plus 1. All right, now we can go ahead and maybe try our direct evaluation. And the reason why that could work is because if you look on top, we don't even have an x at all. Sorry about that. It's impact. So that's kind of like a bonus for us. And as a result, we can then just go ahead and say we have negative 3 on top still. Infinity. Well, let's think about that. We have infinity squared. Well, that's still just infinity minus 2 plus, same thing over here, infinity squared is still just infinity plus 1 underneath that square root. Oops. And then we end up with the square root of the square root of infinity minus 2 is still just the square root of infinity plus the square root of infinity plus 1 is still the square root of infinity. Still have negative 3 on top over the square root of infinity plus the square root of infinity. If you think about it, infinity is not actually a number. It's technically a term that's used to describe that it just keeps going forever and ever and ever. So if you have pretty much really this whole thing would just come out to be infinity. Likewise, this one. But pretty much it would be like the same thing as saying if you had 2 square root of infinities, but it doesn't really matter because the entire bottom is just going to come out to be infinity. And as a result, you have some number on top and something going really high on the bottom. And as a result, if you think about that, if your bottom is going up and up and up and up to some really high number, let's say 10 billion, well, you have negative 3 over 10 billion. This is just an example, by the way. Well, that is, if you think about it, an incredibly small number. I mean, it's really, really tiny. To the point where if you keep going and going and going and going and going and going with your numbers on the bottom, it will eventually just approach that limit of 0. So just a little kind of piece of information to keep in mind as you have infinities on the bottoms in your denominators. All right. So again, that is problem number 3M from the summer packet.